Dear children, we are moving on to the next chapter in part A of your economics textbook, that is Statistics for Economics. Now the name of the chapter is Measures of Central Tendency, and that is the fifth chapter in your statistics textbook. Now regarding the lesson Measures of Central Tendency, before moving on to the concept in detail, let me introduce that particular concept, the measures of central tendency. What is meant by this measures of central tendency? Now let me read the definition given by the for measures of central tendency. What is a central tendency? A central tendency refers to a central value or a representative value of a statistical series. So the definition says that the central tendency is a central value or a representative value of a statistical series. You have learned what is a statistical series in your second chapter. Now, a value which represents the whole statistical series is known as a central tendency. What do you mean by that? Now, the statistical series, now what is the main use of the statistical series? We collect the data in order to investigate certain things, isn't it? We have learned it about the collection of data, then organizing the data and representing the presentation of data in different ways. We collect the data for the proper analysis of our study. Then we arrange it according to the statistical series. Now when we look into the statistical series, we should get a clear-cut idea of the work that we are doing. Now a similar example which I can give you for that, a teacher who is handling 4 classes in class 11, 11A, 11B, 11C and 11D, and she is an economics teacher in all these divisions, and she has conducted a test paper on economics or statistics or whatever may be, and she has corrected all the papers, and she has collected the marks of all the students of all these 4 divisions. Now as a teacher, she is responsible to hand over the marks to the management, right? Now if authority is asking a feedback regarding which class is better, which class is performing better in statistics or economics, teacher should be able to give an answer. Now, if the teacher is analyzing the marks of each and every student of all these divisions, she will not be able to give a clear-cut idea regarding which class has performed well. Now, the marks will be scattered. In one particular class, there will be students who will score very high marks, average and below average marks. So this will be spread among the 4 divisions. Therefore, the teacher will find difficult to give a proper analysis on which class is the best performer. So for that, what the teacher does is, teacher will calculate the average, isn't it? Now how the teacher will calculate the average? Teacher, for example, the class 11A students, the marks of all the students will be added together and it will be divided by the number of students. Similarly, for class B, she will be adding the marks of all the students and divided by the number of students. Similarly, she will be doing the same way for all the 4 divisions. After doing that, by adding the marks of all the students by dividing the number of students, she will get the average. That means for each class she will get a representative value. So the marks of all the students is summarized into a single number. That is known as the central tendency. So teacher has used the tool known as average. In fact, arithmetic mean, which you have learned in class 10, isn't it? She will find out the average of all the classes, and based on the average she will be able to say which class has performed well in the test paper. But the teacher cannot say how many students have secured less than 10. If it is out of 50 marks, the teacher is not able to say how many students have secured less than 10 or less than 20, like that. But teacher will be able to say the average marks performed by the whole class. So this helps the teacher to compare the data very easily. On the other side, if the teacher is trying to compare the data by analyzing the marks of each and every student from all the divisions, she will not be able to arrive at a conclusion. Therefore, there the central tendency helps very much. So, the statisticians use the central tendency in order to summarize a particular data, in order to find out a representative value of the whole data. So, now let us come back to the definition. The central tendency refers to a central value or a representative value of a statistical series. For a particular statistical series, here the marks of 11 A, B, C, D, all these are statistical series. So, there will be a representative value for that statistical series, that is known as central tendency. So, like how the teacher has used the measure of mean or averages, the central tendency helps to reach a conclusion. Now, the central tendency is also called the measures of location. So, this is the another name for central tendency, measures of location. It helps to locate. Thus, the measures of central tendency refers to all the methods of statistical analysis by which averages of the statistical series are worked out. So, all the measures, it refers to all the methods of statistical analysis by which averages of statistical series are worked out. So, if you are working out the averages of any statistical series, all those methods we call it as measures of central tendency or the measures of location. Now, with the example, I think you have got a clear-cut idea regarding the central tendency. Now, mainly there are three measures of central tendency. The first one is mean, as you all have learned in class 10. Second one is median, and the third one is mode. So, there are three measures of central tendency. One is arithmetic mean, the second one is median, and the third one is mode. So, in class 11 we will be concentrating on all the three measures of central tendency, mean, median and mode. Now, types of arithmetic mean. How many types of arithmetic mean we are going to how many types of arithmetic mean we have to learn? So, the first measure that we are going to learn in central tendency is arithmetic mean. We will concentrate first on arithmetic mean. So, we are moving on to the types of arithmetic mean. There are two types of arithmetic mean. One is simple arithmetic mean and the other one is weighted arithmetic mean. So, you need to learn only simple arithmetic mean this year. So, the first measure of central tendency that we are going to learn is arithmetic mean. There are two types of arithmetic mean. One is simple arithmetic mean and the other one is weighted arithmetic mean. So, we have to learn only simple arithmetic mean. Now, the simple arithmetic mean, we need to learn the calculation of simple arithmetic mean for all the three series: individual series, discrete series and continuous series. So, the calculation of simple arithmetic mean we have to learn for all the series: individual series, discrete series and continuous series. Now, you know what is the difference between these three types of series, right? Individual series is a type of series where there is no frequency, isn't it? Discrete series, it is a type of series where frequency will be given along with the x values. Then continuous series, what is the feature of continuous series? Frequency will be given along with the x values and x values will be given in the form of class intervals. These are the three features of the three series, isn't it? Individual series is a series with no frequency. Discrete series, frequency will be there along with the x values. Continuous series also you have the frequency along with the x values, but x values are given in the form of class intervals. So, you have to learn the calculation of arithmetic mean for all these three series. Now, mainly we will be using three methods for calculating the arithmetic mean in all these series. So, the three methods that you have to learn are direct method, shortcut method which is also known as assumed mean method, and the next method is step deviation method. So, you will be learning all these three methods. The first method is direct method. Second method is shortcut method or assumed mean method, and the last one is a step deviation method. So you will be doing arithmetic mean in all the three series, individual, discrete and continuous series, by using the methods direct, shortcut and step deviation method. Now let us start first with the individual series. Now in the individual series you have to learn only two methods. First is direct method and the shortcut method. For discrete and continuous series you have to do all the three methods, but for individual series you will have to learn only direct method and shortcut method. Now we will move on to individual series. Now individual series, once again I am reminding you, individual series are those series where no frequencies will be given, only the x values will be given. Okay. Now the first method that we are going to do with individual series is direct method. Now I told you only two methods have to be learned here, direct method and shortcut method. So as per the direct method, how do we calculate arithmetic mean? Arithmetic mean is represented by the symbol, as you all know, x bar. X bar is equal to sigma x by n. What is the sigma x? Total of x values. Total of x values. So total value of items, that is known as total of x values, divided by n, capital letter N. What is this N? Number of items. How many items are there? Now I told you here there is no frequency, only x values will be there for individual series. Therefore as per the direct method, x bar is equal to sigma x by n, where sigma x is, sigma means total, sigma x is total of x and n is number of items. So this is the formula, x bar is equal to sigma x by n. Now the first example that we are going to see is pocket allowances of 10 students are 15, 20, 30, 22, 25, 18, 40, 50, 55 and 65. So 10 students are given pocket allowances. Okay. Now pocket money is given for them and the values of the 10 students, the pocket money of 10 students are given here as 15, 20, 30, 22, 25, 18, 40, 50, 55 and 65. Now you are asked to find out the arithmetic mean of this individual series using direct method. How to find out using direct method? Remember the formula, that is x bar is equal to sigma x by n. What is meant by sigma x here? Now here pocket allowance is 15, 20, 30, 22, 25, 18, 40, 50, 55 and 65, all are x values. Now how will you find out n from here? So x values are all the pocket allowances given here and n is number of items. How many numbers of items? How many students are here? Here item means students. How many students are there? 10 students. So n is 10 and sigma is x you need to find out. Now let us find out sigma x. To find out sigma x, what you have to do? Sigma x is equal to add all the pocket allowances, and by adding all these pocket allowances you will get the value as 340. Now you know number of observation or students is 10. Apply the formula, x bar is equal to sigma x by x bar by sigma x by n. Now what is sigma x? You know sigma x is 340. We have written here. Divided by number of observation is 10. So you will be getting the answer as 34. So the single value which is representing this statistical series is 34. Okay, thus that is the way we find out the arithmetic mean in an individual series using direct method. Now the next method that we are going to do is shortcut method. So mainly there are three methods: direct method, shortcut method and step deviation method. For individual series you will be using only two methods: direct method and shortcut method. Next is shortcut method. What is shortcut method? As per the shortcut method, the formula is x bar, arithmetic mean, is equal to a, capital letter A, plus sigma d by n. What is this A? A is assumed mean. and D is deviation. It is small d, that is deviation. What is this deviation? X minus a. All the x values should be deviated from assumed mean. You have to find out the difference of all the x values from assumed mean. Now, what is this assumed mean? How to take this assumed mean? Now, you have the x values in your data. For example, if we refer the previous example, pocket allowances, all pocket allowances are x values. From the x values, take any value as an assumed mean, that is A, capital letter A. Any value you can take and that will be assumed mean, that is A. So, you got A. After finding this assumed value, all the corresponding x values, take all the corresponding x values and you have to deviate those x values with assumed mean. Now, let us see how do we do that. After that, you have to apply the formula x bar is equal to A plus sigma d by n. Now, here is the pocket allowance. I have written here as 15, 20, 30, 22, 25, 18, 40, 50, 55 and 65. I told you all these are pocket allowances. From this pocket allowance, I have taken one particular number as A, assumed mean. You can take any number, either 15 or 20 or 25 or any number you can take as an assumed mean. I have taken here as 40 as the assumed mean. Now, the next step is to find out the deviation of all these x values from this A. That is what I have written in the next column. D is equal to x minus A. What is the first x value? 15 minus what is assumed mean? 40. Second x value 20 minus the assumed mean value 40. So, likewise all the x values should be deviated from assumed mean. Now, after deviating that, you will be getting the values as 15 minus 40, 25, 20 minus 40, 20, 30 minus 40, 10, 22 minus 40, 18, 25 minus 40, 15, 18 minus 40, 22, 40 minus 40, 0, 50 minus 40, 10, 55 minus 40, 15 and 65 minus 40, 25. So, in order to find out the arithmetic mean using this method, what is the formula? It is x bar is equal to A plus sigma d by n. That means after finding d, what is d? X minus A. That is what we found now. After finding this x minus A, you have to find out the sigma of x minus A or d. What is sigma of d? To find out the total of this. It can be divided into two sections, isn't it? Here you have 40 minus 40, which gives you 0. So, the values above this 0 are negative values, isn't it? 15 minus 40, isn't it? For 20 minus 40, all these are negative values, isn't it? I have forgot to write here negative. All these are negative values. So, by adding all these negative values, you will be getting 110, isn't it? Now, after this, all the values are positive. 40, 50 minus 40, 55 minus 40, 65 minus 40. The values are 10, 15, 25. If you add those together, you will get 50. Okay. So, minus 110 plus 50, that is sigma of d, you will be getting as minus 60. So, sigma d is minus 60. So, in the formula, you got this value of sigma d as minus 60. Now, what is this n? N is 10, isn't it? So, minus 60 by 10, what will you get? You will get it as minus 6. Now, what you have to do? Substitute the value. X bar is equal to A plus sigma d by n, you know it is minus 6. So, the final answer is x bar is equal to A is 40 plus sigma d by n, you know it is minus 6. So, 40 plus minus 6 will give you 34. So, the answer you got by two methods are the same. Arithmetic mean is 34. So, the whole data is summarized. Thus, it is represented by a single value as 34. So, by using both the methods, direct method and the shortcut method, you got the same answer. So, once again I repeat the formula: individual series, direct method, x bar is equal to sigma x by n, where sigma x is total of x value, n is the number of observation. Second method is shortcut method, which is also known as assumed mean method. According to that method, x bar is equal to a plus sigma d by n, where n is the number of items, a is the assumed mean from any x values, and sigma d, total of d. What is d? Deviation. How do you find out deviation? X minus a. Take the difference of all the x values from assumed mean. That's all. Thank you.